Let's walk through what actually occurs inside a skin cell when it gets hit with too much ultraviolet radiation, because understanding this process really helps explain why sun protection matters so fundamentally. Your skin cells are incredibly complex little factories, constantly making proteins, copying DNA, responding to signals from neighboring cells, and maintaining all the machinery necessary for life. When UV light floods in, it disrupts all of these processes simultaneously. The first thing that happens is direct molecular damage. UV radiation has enough energy to break chemical bonds, and it does this somewhat indiscriminately. DNA molecules, which contain all your genetic instructions, are particularly vulnerable. The UV light can cause adjacent DNA building blocks to bind together incorrectly, creating what scientists call DNA lesions. Your cells have systems to detect and repair this damage, and in many cases, they do a remarkably good job. Specialized repair proteins scan the DNA, find the problems, cut out the damaged sections, and rebuild them correctly. But here's the thing, this repair process isn't perfect, especially when the damage is extensive. If a cell receives overwhelming UV exposure, as happens during a sunburn, there might be hundreds or thousands of DNA lesions to repair. The repair machinery gets overwhelmed and starts making mistakes. Sometimes it repairs things incorrectly, leaving permanent mutations in the genetic code. Other times it can't keep up with the workload, and damaged DNA gets passed along when the cell divides. Simultaneously, UV radiation generates what are called reactive oxygen species inside cells. These are highly unstable molecules that cause additional damage to DNA, proteins, and cellular membranes. It's like the UV light starts a cascade of destruction that continues even after the sun exposure ends. Your cells have antioxidant systems to neutralize these reactive molecules, but again, intense exposure can overwhelm these defenses. Now, healthy cells have a backup plan for all this. If the damage is too severe to repair properly, the cell can activate a self-destruction program called apoptosis. This is actually a good thing because it prevents damaged cells from sticking around and potentially becoming cancerous. You can think of it as a fail-safe mechanism. But UV radiation can damage the very proteins that control apoptosis, meaning cells that should die might not receive the proper shutdown signal. At the same time all this is happening, the damaged cells send out distress signals that alert the immune system, triggering that inflammatory response we talked about earlier. The immune cells rush in and start releasing all sorts of signaling molecules. Some of these promote healing, but others can inadvertently support the survival of damaged cells. What we end up with is this complex scenario where cells are simultaneously trying to repair damage, deciding whether to survive or die, sending and receiving immune signals, and dealing with ongoing molecular stress. When exposure is moderate and infrequent, most cells handle this pretty well. But repeated or intense exposure pushes cells into a state where they're constantly struggling, repair systems are chronically activated, and the chances of something going permanently wrong increase substantially. That's the cellular reality of too much sun.